So lesson 1.2 is transformations of functions. These are transformations you would have seen at other times, okay? They're not going to be brand new by any means, but we're going to look at how they happen in the equation. So we're going to look at what adding or subtracting a number in an equation will then do to the graph. So I start off with, I put this chart in here, and this is a similar chart to what I used in my past Algebra 2 class. And the students always, you know, they kind of live and die by this. It's very helpful to have until you become familiar. So let's kind of run through this, and then we'll kind of go through our absolute value here. So up here, f of x representing the basic function. So the equation that's already there. Now, notice, if there is a plus c, so if you have the equation and there's a plus c at the end, what's going to happen? My graph is going to go up c. And so c could be, say, 3 units. So if your equation has a plus 3 on the end, my graph is just going to scoot up 3. And I'll demonstrate that in a graph here in a moment. If you have a minus c at the end, you're going to move down c. Now, some of you guys experimented in Desmos on Friday and discovered a little bit of this, didn't you? Some of you guys, in your class, you guys could actually still work on Sophist, so you guys weren't all in Desmos on Friday, but x plus c and x minus c. So if you have x plus c, so x plus or minus a number, and it's within the parentheses with the x, or today it's going to be within the absolute value bars with the x, then instead of going up and down, that's going to take my graph left or right. Now, what's the catch to notice here? Or at least it's a catch in my brain. If I see a plus c, my graph is going to go left. If I see a minus c in parentheses or absolute value, it's going to go right. So I always say when you're going left or right, it's going to go opposite the direction of the sign. Okay, that's what I always mention there. Reflections. You know what a reflection is, yes? Reflection, you're just flipping it. If there's just a negative in front of the equation, we're going to flip across the x-axis. X-axis being your horizontal, right? So go from up to down or down to up. If there's a negative on the x specifically, then we're going to reflect across the y-axis. The y-axis being the vertical axis. I will tell you, at least for today, the one we're more working with when we graph and stuff is reflecting across the x. And then notice the next two. It's a f of x. So that's saying what happens if we take a number and we multiply it by the equation. So taking a number and multiplying it, it's either going to stretch it or I use the word compress. Have you guys seen the word compress or have you seen the word shrink before? Or have you not seen these words? Okay, I don't know. So a vertical stretch means we're going to take the graph and vertically we're going to stretch it up so it kind of becomes skinnier. Where a vertical compression, we're going to compress it. So think shrink. And when you squish something down, what happens when you squish something down? It's also going to get wider, yes? Right? Think, I don't know, take a marshmallow. When you squish it down, it gets shorter, but it gets wider at the same time, doesn't it? Okay. Now, that is if the number is multiplied out front of the function. That's going to be a stretch or compression. I put these on here. We're not really going to see these today, but I still put them on here because there is a little bit of reference to horizontal stretch and compression in your homework. So I'm always trying to make sure that we are planned for homework here. And the horizontal is specifically within the equation, it is x divided by that number. And if it's, instead of multiplying by this number out here, if it's x divided by the value, it's a horizontal stretch or horizontal compression. And I forgot to tell you, how do we know if it's a stretch or compression here? Well, if the number is bigger than 1, it's going to stretch it. If the number basically is the same if the number is less than 1, it has to be positive, but we're going to compress it down. Same thing is true on the horizontal stretch and compression. Number bigger than 1 is horizontal stretch. Number smaller than 1 is horizontal compression. Now, horizontal stretch. Where's horizontal stretch going to take me? horizontal going this, like, left and right yet. So horizontal stretch is going to make something what?
Go up.
Not go up, but go out. Okay? What about horizontal compression? If you take something and compress it horizontally, where's it going to end up going? It's going to go up, yeah? If you take that marshmallow and you squish it from the sides, it's now going to get
Longer.
taller. Okay? Taller, longer, what, you know. Now, with this in mind, here's the connection you need to make. Are you seeing this? A vertical stretch and a horizontal compression are linked. Okay? A vertical stretch could also be said as a horizontal compression, because if you're compressing something horizontally, it's going to get taller and it's going to be a vertical stretch. Guess what else that means? Yeah. Vertical compression and horizontal stretch are related. If I vertically squish something down, it's horizontally going to stretch and get wider. Am I making sense of what I'm saying there?
Yes.
Okay. And obviously, some of this will make more sense as we get into examples. Now, f of x is what we used here. F of x just represents whatever the parent function is. And I use the parent function, like the parent function we're going to use today, is because everything we talk about, for the most part, is going to be this absolute value. So the parent function is the y equals absolute value of x. It could be y equals x squared as the parent function. That will probably be what it is tomorrow. But the parent function is just the original function that we then altered. So, before we get started on practicing our translations, our shrinks and compressions, and all of that, we need to know how to graph a basic absolute value graph, yes? When it says in homework, graph this absolute value function, and it wants you to move it left or move it right or something, you can't do that if you don't know what the original graph looks like. So that's what I've got to get us today, is what does the original graph look like? So I have an XY chart set up for us. Not saying you need to do XY charts all the time. There's a few in homework, but, you know, if we don't know what a graph looks like, we do an XY chart, right? What are good X values to pick? 0, 1, 2, always good, right? Now, if you only need 3, I sometimes could go with 0, 1, 2. What is also good to throw in? Probably some negatives. And this one, for instance, if we don't throw negatives in here, we're not going to have the right shape of the graph. If you only throw positive values into this one, we're not going to have the right graph. So I'm going to use -2, -1, 0, 1, and 2. Okay, what happens when we put it into this equation here? Y equals absolute value of x. So what happens if we say y equals absolute value of -2? What does absolute value do to a number? Makes it positive, right? There's nothing to do in the absolute value, so absolute value is officially distance from 0. Well, -2 is 2 away. So the absolute value of -2 is?
2.
Positive 2. What's the absolute value of -1?
1.
1. What's the absolute value of 0?
0.
0. What's the absolute value of 1? Absolute value takes the value inside of it and makes it positive. If it's already positive, it just stays positive. So it's going to be 1. And absolute value of 2 is 2. Okay. Graph your dots. You know how to graph this, yes? -2, 2 means I'm going to go left 2, up 2. -1, 1. Left 1, up 1. 0, 0. 1, 1. Right 1, up 1. 2, 2. Right 2, up 2. Is it a line? No, it's not. What is it? A V? Okay. Absolute value is always going to be a V. every time. Absolute value, so the V in value, it's going to be a V every time. You had a little bit of these in your last homework, but I told you to do them on Desmos, right? Well, they always came up to be V's. Now, a little bit to know about that absolute value V. The basic absolute value V is always going to be centered where? Where does it start? What is this ordered pair?
0, 0.
0, 0. And 0, 0 is called my vertex. So when it asks you about the vertex of your parabola, or not parabola, strike that, the vertex of your graph, so the vertex of your absolute value V, it's the point of the V. Now, axis of symmetry. You remember what axis of symmetry is? I don't know. Yes, no?
No.
If it's symmetry, does that tell you something?
Yes.
What's symmetry going to do? Say. It's going to cut it in half, right? Has to make the same pieces the same, or the both sides the same half. Where is the axis of symmetry? Where is this cut in half?
The y-axis.
In this case, it's the y-axis, yes? Now, I like that. I'm going to put y-axis here. Officially, we need a better name than y-axis. And what is the name of that equation? X equals 0. And we'll talk about some other axis of symmetries, but your axis of symmetry is an equation of a line. It's always going to be x equals, and here's your hint. What was the x value of my vertex? 0. So what's my axis of symmetry? X equals 0. So that connection is always going to be there every time. Now, absolute value V's, folks. Here's how I like to teach. When we get to this next part and we're looking at translations, I like to take that vertex and count it over. Left, right, up, down, whatever it is. And then what do you notice about the sides of the V? What kind of relation do they have?
They're infinite.
Okay. They're infinitely going up. They're linear. How are they infinitely going up and linear?
The arrow.
But what's my relation here? They're going up 1 over 1? Up 1 over 1?
Yes.
You could call that, what's the math word for that? Slope, right? I'm throwing lots of good words out for you. Okay, you could call that slope. But so a traditional absolute value V has a slope of 1. Technically, that's a slope of 1 on the right. The left, I always just say reflected over there. Or it's going to have the negative slope, because that has a slope of negative 1. Okay, you got some information here, right? So you can use this. Because that's what we're going to do. We're going to use this. Okay, this is your reference. So you have this in notes when you forget what it looks like. I think I have the next. Okay. So we're going to start with the vertical and horizontal translations. Do you know what I mean, translation? Do you remember? You're translating something, you're taking it and just moving it. You're not flipping it, you're not rotating it, you're just moving it. So left or right, up or down, whatever the case is. Okay, so the directions. Graph each function. Identify the transformations. So transformations, it's all these different movements. Whether it's translations, reflections, compression, shrinks, whatever. So identify the transformations. We're going to use words. The vertex and the axis of symmetry. So as you look at this, y equals absolute value of x plus 4 plus 2. Hopefully it won't go over too poorly. I went ahead and combined the pieces here. Thoughts on what that 4 and 2 tells my graph to do? And my hint is going to be, you have a chart up top in your notes, right? It's on my previous screen, but glance up at your chart. So what's this plus 4 telling me to do? Left? Because if I go back here, that +4 is like having a +C in the parentheses. So this +4 is going to tell me to go left. So that was in the absolute value, so left or right, opposite the sign. What's the +2 telling me to do?
Left to, or up to, or down.
It's either up or down.
Down.
Okay. And I'm going to say it's up or down because it's not in the absolute value. It's at the end. So since it's at the end, it's going to be up or down. Since it's a plus a number, it's going to go up. So those are just a few little notes to myself so I know what I'm doing. Can we graph it?
Yep.
Okay. So where was my vertex at last time?
0, 0.
0, 0. What are we going to do with that vertex? We're going to take that vertex and we're going to move it left 4 and up 2. So right there, I'm going to take 1, 2, 3, 4, 1, 2. Can you guys see those graphs well enough?
Yeah.
Okay. I know, I forgot to move you. Are you making do okay back there for today? Okay. I thought about that partway through my notes. Left 4 up 2. Now, what does the rest of the absolute value graph look like? What's it do from that vertex if we don't have anything else telling us to do anything different? It's going to be a V, right? How do those sides of the V go? Up 1, over 1. Up 1, over 1. Up 1, over 1. Can you make a couple of dots for me?
Yes.
I don't want you to just randomly draw a V from that vertex. I'm going to be more specific than that. So I do want, my thing would say at least 2 sets of dots. So I'm going to go up 1, over 1, up 1, over 1. On the left, I'm going to go up 1, over 1, up 1, over 1. And then, connect it. Now, there's some information they wanted from us. First of all, identify the transformations. If I put these in official words, left 4 up 2, what officially did we do? We didn't just go left 4 up 2, we what? Translated. Okay? So I am going to say here that we translate left 4 and up 2 units. Here's what I definitely don't want you to do. I don't want you to just tell me left 4 up 2. Translate, move, shift. I want some verb in there. I know I'm not an English teacher, but so we translate left 4 and up 2 units. And then think about your vertex when you're ready. There was a vertex originally on the original graph of 0, 0. Where is the vertex on this graph?
-4, 4, 2.
Yeah.
-4, 2.
We went left 4, and then we went up 2. So my vertex is left 4 up 2. I'm going to argue that you wouldn't have had to have graphed that to figure out your vertex. Okay. You can look right here, and we'll talk about that on the next page. We are also asked for an axis of symmetry. So an axis of symmetry, what line is cutting this in half?
-4.
Okay, and it's what x value does my vertex run through? Now, don't just tell me -4. X equals -4. So your axis of symmetry is always x equals a number, and the number is always the x value from the vertex. Okay. This isn't horrible, is it?
No.
Is this hopefully going better than lesson 1 did?
Yeah.
Okay. I know. I was frustrated with how lesson 1 went, so I'm trying to redeem myself. Hoping it's working here, because I didn't like how lesson 1 went. It was kind of a big, ugh. Okay. So, other example, do you know what you're doing in this example? Y equals absolute value of x minus 3 minus 5. Now, let me ask a question here. Could I go ahead and subtract this minus 3 and this minus 5? Could I have added the plus 4 and the plus 2?
No.
And the answer is no, because this one set is in absolute value, yes? Okay. So, what can you tell me about this? What do you got, Landon?
You could go right 3.
Okay. He sees a minus 3 inside the absolute value. So that's going to be left or right, opposite the sign. So right 3. Look back on your chart if you're trying to decide if Landon's right or not. Okay. What else are we going to do? There you go. Where else, Gatlin?
Down 5.
Okay. A number at the end is up or down with the direction of the sign. So minus 5 takes me down 5. Now, if you want to go ahead and write out if we identify our transformations, what is it we're doing here? We're going to translate right 3 and down 5 units. Okay. I'll come back for my vertex here in a little bit. Have you graphed it?
Yeah.
Am I behind?
Yeah.
Is that, you guys are ahead of me?
Yeah.
Not complaining there. Okay. What am I going to do? My absolute value function normally starts at
0, 0.
0, 0. We're going to take that 0, 0 point and move it.
3 right, down 5.
1, 2, 3. 1, 2, 3, 4, 5. So there we go. There's my new point. From that point, how do I get the sides of the V? Do I just get to draw them in anyhow I want? No. I want some extra points, and we're going to go
Up 1 over 1.
up 1 over 1.
To make a V.
Realize my absolute value V when I'm drawing them, I'm putting arrows on the end, yes?
Yes.
Yep.
The comment was made earlier that it's going on infinitely. I agree. Okay. Did you write down vertex?
Yeah.
What did you write down?
3, negative 5.
Since we went right 3, down 5, 3, negative 5. And did you write down axis?
Yes.
What did you write down for your axis?
X equals 3.
Okay, it's always x equals a number, and it's x equals 3. As you start looking at your vertex, realize my vertex is just these two numbers here, yes? I just have to do the opposite sign of the first one, and then the sign of the second one. Okay, we can handle that, right? Yep. Obviously, when you do homework questions or stuff like Math Excel, that your graphs, you're more picking from their graphs, as opposed to actually graphing these. Now, come quiz time or something like that, I'll still want you to graph them. But Math Excel, Savas in this case, will not exactly. Okay, a couple more graphs. What's different here?
Fractions.
Okay, threw in some fractions.
And the absolute value.
Okay. Absolute value of x. There's no, what is there not on this one?
plus or minus on the
Yeah. No adding, subtracting. So is my graph going to move left or right or up or down? No.
Be a line.
Okay. Now it's still going to be a V. Because it has absolute value of x, it's still a V. It's not moving anywhere. But what does this 2/5 do? Oh, yep, I see people looking back. I'm going to scroll back a couple of pages here. Okay, we're not adding and subtracting. There's not a negative out front, or there's not a negative. Is there a number multiplied out front? Isn't 2/5 a number?
Yes.
It is. It's a number, even though you guys see it as a hideous fraction. It's a number, okay? It's a value. So we're multiplying by a number out front. So multiplying by a number out front is going to take my absolute value V, and which are we going to do here? Are we going to vertically stretch or vertically compress? Where does 2/5 fall? Is 2/5 greater than 1? Or is it between 0 and 1? It's between 0 and 1, isn't it? It's a fraction where the smaller number's on top. So this is going to be a vertical compression. So when I write my transformation, I'm going to go ahead and do that. I'm going to write this as this is going to be a vertical compression. So you need to be in the habit of saying, is it vertical or horizontal? Is it a stretch or a compression? And it's a vertical compression by a factor of what value here? 2/5. Okay, that's the only thing we're doing to this absolute value V. So where's my vertex going to be? 0, 0. My graph is not moving left or right, up or down. It's staying. I had nothing telling it to move. Now, with that in mind, we have that 2/5 out front. What does that make you think? What? Slope, yes. Now, officially, is it slope?
No.
No, officially, it's a vertical compression. However, can the idea of slope help us here?
Yes.
Yes. Okay, so really what we're going to do here is we're going to do a slope of positive 2/5 on the right branch, and then we're going to reflect it on the left branch, on the left side of the V, if that makes sense. Okay, so I'm going to go ahead, let's see, I'm going to write a little note up here. You might want this. We're going to do a slope of 2/5 on the right, and then we will reflect that on the left. Because if we just do slope of 2/5, I mean, the key is we have to have two sides of a V, yes? If we just always do 2/5, you're just going to end up with a straight line. Now, I didn't think about this. Slope. What's our phrase for slope? Rise over run, yes. Just friendly little reminder here. Rise over run. So the top number is my rise, which tells me to go where? Up to. Bottom number is my run, which tells me to go horizontal. Since it's a positive run, we're going to go right horizontal. Is this coming back to you?
Yes.
You saw it in Algebra 1. You saw it a little bit in geometry too, didn't you?
Yeah.
But, okay. I'm trying not to assume we remember anything. So I'm going to rise 2 over 5. You can rise 2, run 5 again if you want. Okay. There's the right side of my V. There's a big part of me that just want to says, okay, make the left side look the same. Can I say that? I mean, that makes sense, doesn't it? Yeah. Okay, officially, this is where I'm saying, okay, we're going to reflect it over. So now, there we went up to right 5. To get the other side of my V, I'm going to go up to left 5. And there's my V. What happened to my V?
He got compressed.
He got compressed. Does it look like it got compressed? As it got compressed, it got wider. And so, I mean, technically, it's going to be the same height as the other one, you know, because they go on infinitely, but it looks smaller. It looks shorter, doesn't it? So this is a vertical compression. Technically, we could also call it a horizontal stretch. Okay, we could also call it a horizontal stretch. Okay, questions on that? Okay, tell me if you have questions, because otherwise I might keep moving. Let's try the next one. Y equals -2 absolute value times the absolute value of x. Okay. If I go back to my chart, thoughts, where does that fall? I just heard two totally different things. I heard a vertical stretch and I heard a reflect. Can it be both? Okay, so here's the deal. It's a -2 out front, isn't it? Does negative, so when we look here at AF of x, right? The options here are A is bigger than 1. Is -2 bigger than 1? No.
Nope.
Or A is between 0 and 1. Is -2 between 0 and 1? No. So they are both right. We have to separate this. The 2 tells me it's a vertical stretch. Okay? That factor of 2 out front is a number bigger than 1. It's going to be a vertical stretch. Where's the negative go, though? The negative, go to your reflections. When you have a negative out front, a negative out front right here is a reflection across the x-axis. So the x-axis being my horizontal axis. So instead of a right side up V,
Down.
upside down V. Okay? So there's not just one, there are two transformations here. And I will tell you, the common mistake is to say it's a vertical stretch of -2. That's only half right. Okay? So I'm going to write this out and then we'll work on graphing it. So it is a vertical stretch by a factor of 2 and a reflection across the, since the negative is out front, it's across the x-axis. Okay, so, a moment to write. Let's start with the basic question. Where's my vertex? 0, 0. Did I move left or right or up or down?
No.
No, so my vertex is still 0, 0, and so we start moving around. Now, last time we used a slope of 2/5, which took me up to over 5. Thoughts on how we can do this? Because there's two different ways we could talk about this. Jaron, what are you going to say?
2/1.
Okay. And then if we do a slope of 2/1, what are we also going to have to do? Okay. You either have to, and this is where we can do it two different ways, is we could kind of say, okay, I'm going to go up 2/1, up 2/1, up 2/1, but then what do we have to do eventually? We also have to reflect it. So the other option is, could you make one of those numbers a negative and do a negative slope? Because where's a negative slope going to take me? down. Okay, so there's options here. But what I would say is we can do a slope of -2. It's still on the right. And then reflect on the left. I hate to use the words common sense because people complain I don't have common sense, but it's reflected. Logic says in the end you have to make sure your graph is upside down, correct? So if we think of -2 as a fraction, (2/1), so I would say rise -2, run 1. So I'm going to go down 2, over 1, down 2, over 1. I can also do the same thing on the other side. I'm just reflecting it. Down 2, over 1 there. What do you notice about this V? It's upside down. Should it be? Yes. Good self-check. Is it the same size as the V's I did on the front of the paper? No. The last one was really wide. This one, if you go and compare it, is skinnier. The skinnier means it is vertically stretched. It's been stretched, it's made skinnier. Or, if you want to think this way, is horizontally compressed. Okay. I did not get through all the notes like I'd hoped. It's all right, though. It's going to take us a few days to get on track between Savas and everything else going crazy. But tomorrow when we come in, I'll kind of pick up here, and I'll talk about general form of an absolute value equation. This is just kind of putting it all together. Okay? We'll look at a little bit of just being able to identify the information without graphing, which I think you guys are already on the same track there. We'll look at a few reflection examples that aren't absolute value. I did throw in a few problems in this homework that are not absolute value. Okay? So, what I'm going to say about the homework. I can't remember if I made it due tomorrow or due on Wednesday. I'll go back and check. But, is the homework due tomorrow? No, because I did not finish the notes, okay? And to me, in my brain, that's common sense, but it's not necessarily common sense because you guys don't know me that well yet, right? So, we didn't finish the notes. Unless I say otherwise, the homework's not due tomorrow. I will make it due on Wednesday. Now, with that in mind, could you start looking at it tonight?
Yes.
If Savas will let you.
Yes.
You can. Okay, I'll be curious to hear if Savas is starting to be more cooperative for everybody. I'm hoping it is. 1-1. Try and get it done today if you have not submitted it. If you're still having Savas problems, let me know. Just make me aware. Okay? And then tomorrow, once we finish these notes, we'll see. I may go ahead and take us a little bit into the rest of the 1.2 notes, or I may wait on those till Wednesday. Okay, see how things go. Questions?
No.
Okay.